Hello everyone, welcome to our second tutorial of abstract algebra focusing on group theory. So in the previous video we looked at the mathematical definition of a group, and then we also looked at symmetry, and in this video we're going to be looking at dihedral groups and would focus on the symmetries of a triangle. So before we look at dihedral groups, I'm just going to write down the properties of a group that we mentioned or that we talked about in the previous video. So a group must have the following four properties. Property number one is closure. Property number two is associativity. And then Property number three is the identity. And then property number four is inverse. So I'm just going to write that there, and we're going to look at those properties in more depth. So what is a dihedral group? A dihedral group basically is a group that denotes the rigid motions of a regular polygon. So a dihedral group is given by dn, and it is equal to the rigid motions of regular polygons. That is what a dihedral group is. And if n is 3, for example, then you have d3. So d3 are the motions of an equilateral triangle. And that is our focus for today's video. The rigid motions of an equilateral triangle. So to do this, we're first off going to define the rotations and the reflections of a triangle. So let's look at the motions of a triangle. So if you take a look at a triangle has, you can do rotations on a triangle, and you can also do reflections on a triangle. So how do I do rotations on a triangle? Well, what I can do is, given a triangle like this, I can do a 120 degrees rotation anti-clockwise or clockwise on this triangle, right? So here's 1, 2, and 3. So if I do a 120 degrees anti-clockwise rotation on this triangle, it's going to look something like this. So this 1 would come down, you'd have 1 there. 2 would move that way, you'd have 2 there. And then the 3 would move up. So just try to picture this in your head. Imagine holding this triangle and trying to rotate it. If you rotate it 120 degrees, it's going to look exactly like what you started with. Now, reflections. You can also do reflections of this triangle. So here's 1, here's 2, and here's 3. I can keep this 1 fixed and then do a reflection along that axis. So if you do a reflection along that axis, what you would get is a triangle that looks like this. So that 1 would stay in its position, but then you have to flip 2 and 3. So 2 would move that side, and then 3 would move the other way. So you'd have something like this, 3 here, and then 2 here. So that would give you a reflection of this triangle along the axis 1. You can also do a 240 degrees rotation, a 360 degrees rotation. 240 degrees rotation means rotate this triangle twice. 360 degrees rotation means rotate this triangle 3 times. And then a reflection, you can do a reflection along this axis, you can do a reflection along this axis, and you can also do a reflection along that axis. Now I'm going to define a set, a group, okay? And then we're going to see that this group that we've defined satisfies all the properties that I've listed here. So let us define a group R. And what is R? The group R means rotations of the equilateral triangle. So it's composed of the following elements. It consists of the following elements: R, R2, and R3, which is equal to the identity element. So you might ask, what is R, what is R2, and what is R3? So whenever, these are just notations that I've written down. So whenever you see R, what is R? This element, I'm talking about this element now. R means rotate (120 degrees) anti-clockwise. That's what R means. Rotate it 120 degrees anti-clockwise. So what do you think R2 would mean? R2 means rotate 240 degrees anti-clockwise. That's what R2 means. You either rotate the triangle twice or you do a 240 degrees rotation. And then R3. R3 means what? It means rotate 360 degrees anti-clockwise. And now think about it. When you do a 360 degrees rotation, you would come back to the triangle that you started with. So let me do an example. So if I write something like this, is just a notation. If I do R of this means take this triangle and then rotate it 120 degrees anti-clockwise. This is going to be our notation. So what is it going to look like when we rotate it? So this one would come down, the 3 would move there, and then the 2 would go upwards. And then you would have a triangle that looks something like this. So the 1 comes down, the 3 moves to the 2, and then the 2 moves up. So if you do a 120 degrees rotation anti-clockwise on this triangle, this is what you would get. That's R. What about R2 acting on the triangle? 1, 3, and 2. What do you think that would be? Well, in this case, the 1 would move 2 spaces, right? 1, 2. That is R2. So 1 will take the space of the 2. So 1 will be there now. Then what about the 2? The 2 will move 2 spaces as well. So 1, 2, 2 will be there. Then 3 will also move 2 spaces. 1, 2. Like that. And R3, let's do R3. I'm going to do R3 somewhere up here. R3 acting on the triangle. So you have 1, 3, and 2. This means rotate the triangle thrice or by 360 degrees. It means the same thing. So what do you think would happen to the 1? This 1 would move 1, 2, 3. Look at that. It goes back to its starting position. And then 3 would move 1, 2, 3. 3 would also go back to its starting position. And then 2 would also go back to its starting position. So look at that. Look at the triangle that we had. It's exactly the same as the triangle that we started with. That is what it means by the identity element. The identity element is basically an element that gives you back what you started with. So one property of the identity is that the identity element composed or acting on any element in the group would give you that same element. That's what it means. And R3 is the identity element here. So that means R3 acting on R2 would give you R2. Right? So don't think of this as algebra. Don't think that this is 3 to the power of 3 and 3 to R to the power of 2. So you do R to the power of 3 plus 2 and then that would give you R to the power of 5. No, that's not how it works. In future videos, I would show you the algebra of group theory. So in this video, I've defined the elements of the group. So R is the rotation of the equilateral triangle. In the next video, we're going to prove these 4 properties. Thank you very much for watching. I'll see you in the next one.